Hey, Great Steel Nation, Sully here with the Barbell Prescription, keeping you strong and healthy in the second half of life. Got another installment of board shorts for you, and today we're going to talk about calibrating your knees out position. Now, as you will know, in our model of the squat, we emphasize a knees out posture as we approach the bottom of the squat, actually from the very beginning of the squat. And this has a number of effects, all of them delightful, brings the adductors into the exercises, moves the body through a more complete range of motion, allows you to get deeper into the hole, and so on. But this knees out posture and our model of the squat in general presupposes that we are using the knee as a hinge joint, primarily as a hinge joint. Why? Well, because it's a hinge joint. That's what it is. It is primarily made to flex and extend. This becomes even more obvious when we look at the knee joint from an anterior-posterior direction. So this is an AP view of the knee joint, part of it anyway, and here we can see even more clearly that the knee is not meant to be a universal or swivel joint, right? The tibial plateau isn't really a plateau. It's got a little mountain in the middle of it, the intercondylar eminence, which is not going to allow torsion on the knee because the knee doesn't do that because it's a hinge joint. And we haven't even talked about the fibula, right, which further restricts the movement of the knee. So the knee is not meant to do this, and it's not meant to do that. It's meant to function as a hinge, and that's what we want to do in the knees out position. However, it's very important to align the femur with the long axis of the foot, or you'll still get some rotation around what should otherwise be a pure hinge joint. And we see this all the time, both in older lifters who have mobility limitations and in younger lifters who are not matching up their femur with the long axis of the foot. And let me show you what I mean by that. It's all about femurs over feet. So let's take the example of a lifter who looks like this from the front. This is a little bit foreshortened because he's already sort of like a quarter of the way down the squat. And his knees, he's anchored his knees out. Good for him, right? He's not going to have knee poke at the bottom. But you can see that one of two things is going on. Either his knees out is too wide or his stance is too narrow. And in any event, he's now got a moment between the knee and the ankle joint, right? So that's going to be a problem. If we looked straight down at his feet, what we'd see is this. This guy's got great hip mobility. He's able to get his knees way out to the side, but his femurs are not tracking over the long axis of his foot. And if his ankle joint is about here, then we can see that his shank, his shin, is not going to be lined up with his femur either. And what that inevitably means is that he's going to have some torsion around the knee joint, right? Some twisting of the femur on the tibial plateau. And we don't want that. Let's look at another example. So this guy is in a situation where either his stance is too wide or he's not getting his knees out far enough, or both. And so, once again, he's going to have a moment in the other direction between his knee and his ankle. And he's going to have twisting of the femur on top of the tibial plateau, which we don't want. And once again, if we look at this straight down, we can see that his knees are inside, right, his stance. And once again, if we say his ankles are right here and we follow the path of his shank looking down vertically, what we're going to see is, once again, his tibia does not line up with the long axis of his femur, which doesn't line up with the long axis of his foot. So once again, there's going to be a rotational force of the femur on the tibial plateau, and we don't want that. What we should be seeing is this. This is the configuration we want to see, where the knees go out just over the toes, maybe just a little bit beyond the toes, and the femur lines up with the long axis of the foot. So again, if we look at this straight down, here's the situation that we have, where the femurs track out over the long axis of the foot. The femur, the thigh bone, tracks out, is parallel to, collinear with the long axis of the foot. And so if we draw the ankle joint, again, looking straight down, it's going to be right here. And we can't draw the shank because the shank is hidden by the femur, right? It's directly underneath the femur. All of these elements are collinear. They're all in line. They're all parallel. So that there's no torsion on the tibial plateau, right? So what we're looking for when we squat, we don't want this. We don't want this. This is what we want right here. Now, if you're young, dumb, full of cum, you want to squat with your knees forward and add that extra stress to your knee, so be it. One day you'll be sorry, but you're not my concern. I'm talking to people 40, 50, 60 and beyond, because these are the people who may have some limitation in their hip mobility, and they can't necessarily always get their knees out, either because of arthritis or an old injury or a knee replacement, something like that. So these people have trouble getting their knees out, and so what they have to do is they have to make an adjustment in their stance and in the angle at which they place their feet on the floor so that they can achieve something like this configuration, even if they have to take a fairly narrow or, in some cases, a wide stance to do it. So evaluate your squat, have your coach evaluate your squat, look at your video, and make sure that you're getting as close to this configuration as possible to minimize unclean forces around the knee joint and to maximize your ability to use the knee as it was evolved to be used, as a hinge joint. You'll be stronger, you'll get better results with fewer knee tweaks. I hope this helps. Until next time, stay strong and stay healthy.